This session is Pivoting in Amazon Clouds with Andres Riancho as your speaker. And thank you, and please enjoy the rest of the Black Hat briefings for 2014.
Thank you. All right. Thanks, everybody. So today, I'm going to tell you a story. This is the story of how, during a web application penetration test, I discovered different vulnerabilities and weaknesses in how this application was set up in the Amazon cloud. This session is going to go through different misconfigurations and issues that you guys need to know when deploying something in the Amazon cloud. So let's get started with the first thing that I found, the first vulnerability, and the only one that's not related with a misconfiguration in Amazon. And I found this very simple vulnerability. This is an HTTP request proxy vulnerability. I'm sure that most of you guys have already seen this, but the basic idea is that if you perform an HTTP request, like in the first line that you see there, let me highlight. In the first line, you perform an HTTP request to a URL that has a URL parameter, and as you see there, the vulnerable web application is going to kind of forward that HTTP request and return the response. So it works like this. I'm at this workstation. I perform the first HTTP request. The target, because it's vulnerable and it has some issues, it's going to perform a different HTTP request to a URL that I can control. All right? Then the response from this request arrives to the target web application and comes back to me, in the initial HTTP request. This is very simple. So I found this and I said, okay, what can I do? I tried different paths. In some cases, for example, what you can do there is replace the URL parameter with something that says file colon slash, and you try to read a file from the file system where the vulnerable web application lives. And it wasn't working, and I tried different tests. Nothing was really interesting, until I thought, hey, this is deployed in Amazon. This is an application that lives in an EC2 instance in the Amazon cloud. So what can I do with that? I have that information and I want to use it. So I tried something. I tried to replace the URL parameter that you see there with that strange URL, the one that starts with 169.254. And in the response, I got that little piece of information. AMI something, something, something. All right? And I was really, really happy. And who knows what's in that IP address? Hands? One there, two. All right. Argentinian guy. Juan, let's go. Yeah. All right. So that IP address is the instance metadata. So when you start any EC2 instance in Amazon, you're going to have an EC2 metadata server attached to that instance. It's going to simply be listening on that IP address, and each EC2 instance has that same IP address. You can only access that IP address and the metadata that it stores from that individual instance. So from instance A, you cannot access the metadata from instance B. But in this case, and because of the vulnerability of the HTTP proxying, I was able to access the metadata from anywhere in the world, all right? Because we had a vulnerable web application living in that EC2 instance. So what's stored in that instance metadata? There are many different things that are stored there. We're going to go through a couple of these. And the first one that I showed you was AMI and a number. So as you can see here, the instance metadata is ordered in different paths inside that HTTP server. And one of the things is the AMI ID. The AMI ID is basically an identifier for that EC2 instance operating system, image, and stuff like that. So some AMIs are public, and if you're an attacker and you know the AMI, you go, you search it, and you might, if that AMI is public, you might be able to identify which operating system is running and with which configuration. So that's good information to have. Something else that's stored in the metadata is a private IP address, the instance type, how many cores, memory, and stuff like that, and where it lives, in which region, in which data center from Amazon that instance lives. So this is how, from an attacker perspective, this is how it looked for me at that point. I was able to forward HTTP traffic to that metadata server and access information from there. All right. I knew that the metadata server stored a lot of information, not only the 4 or 5 things that I already mentioned. And I also knew that there are different tools that usually are used by developers, which know all the different paths where that information is stored. And it's kind of not that trivial to know and to kind of calculate the paths, because in some cases, one path depends on information that you get. One path depends on information that you get from a different path. So I wanted to programmatically access that information, and I'm a Python guy, so I wanted to use the boto library. So I did it, all right? So I wanted to access that remote instance metadata using boto, but boto only knows about accessing that local IP address, that 169 IP address. So I modified boto a little bit using something that in Python we call monkey patching in order to fake those connections, and instead of those connections going from my workstation directly to the 169 IP address, which doesn't make sense because it's not even routed and stuff like that, I modified that in order to forward that HTTP traffic through the vulnerability that I found in the first slide. And this is kind of the simplified code of that, where I monkey patch the access, as I was saying, and I just forwarded in that line that says request.get and the mangled URL. That's the original URL that boto tries to access. And I change it with this pattern in order to forward it through the vulnerable site. So with this simple monkey patching trick, I was able to access in a programmatical way all the information that was stored in the remote instance metadata server. Okay? And I wrote a couple of tools. I'm going to show you mostly one of those, and then I'm going to do a summary of the other one. The first one that I wrote is called Nimbostratus, and it has these tricks for accessing metadata and for doing some other post-exploitation things in the Amazon cloud. So Nimbostratus is going to dump all the EC2 metadata using that mangle function that we were looking for. As you can see there, you have the Nimbostratus command, you have dump EC2 metadata, which is the sub-command inside Nimbostratus. And you need to provide, this is open source, you can download it later, and you need to provide the function that's going to mangle those requests in order to fool boto. All right? We run this, and as you can see there, it's requesting different things, different paths, and afterwards you get the information. In this case, nothing really interesting, other than knowing that there is a security group, which is kind of a firewall in Amazon clouds, and something else that says user data script was reading to user data. All right. So this simple tool was able to dump all the information from that remote instance metadata. But what is user data? You know, the last line that we saw there, what's that? And I was learning. While I was doing this pen test, I was learning. As a result from the pen test, I wrote the tools, but I didn't have any of these tools when I was starting with the pen test. And I had a little bit of knowledge about Amazon, but not a lot. So I had to kind of do some research and learn. When you Google user data Amazon, you're going to find that when you want to start an instance, one of the ways of configuring that instance, and there are different ways, Amazon is really flexible, but one of the ways of doing that, of configuring an instance, is providing a user data script. Something that you need to keep in mind in cloud architectures is that they need to scale, and they need to scale in an automated way. That means that at some point you're going to have 3 servers answering HTTP requests, and at some other time you're going to have 5, and at some other time you're going to have only 1. And those web servers need to know, for example, the domain that they are going to be serving. They need to know which web application they are going to be running, the Apache configuration, and a lot of things. And when you start an instance, one of the ways of configuring that instance is using user data. User data script is just basically you take an instance that's kind of by default Ubuntu 12 or 4, and you get a user data script, you merge those, and you get a configured instance that can receive HTTP traffic, right? So user data scripts have good information. They need to know from where to retrieve the source code of the web application. They need to run some steps. And we were able to download the user data script for that web application that we are pen testing. And in my case, I was very lucky. It's not always like this. I found that the user data script had a lot of information. The user data script is just a script in any language, and in my case, it was something similar to this. It had a repository where the web application lived, the private keys and the public keys to access that repository and download the source code, and different functions for actually getting the source code, configuring Apache, configuring, I don't know, Nginx, and different things. So with this, I had access to the source code of the web application that was running and I was trying to pen test, I had access to the source code, which was really good. I had the keys to that web application. At that point, usually in kind of a regular pen test, what you continue to do is you download the source code, you analyze it, you find vulnerabilities by doing source code review, and you test those vulnerabilities in the live production system. But that's kind of boring. Doing source code review is a lengthy process, takes time, takes effort. And I started to think, hey, why is this running on Amazon? Usually, when you run on the Amazon cloud, it's because you want not only to use an EC2 instance or n EC2 instances, it's because you want to use different services from Amazon. You want to use S3, you want to use DynamoDB, you want to use different things. So let's say that you want to build an Instagram clone. You're going to, for example, store the images in an S3 bucket. And you're going to store the metadata about those images, like who owns which image, in a NoSQL database, such as DynamoDB. And that's great. It's a great architecture. Something that you need to note is that in order for the web server to be able to store the images on S3, it needs to have some kind of credentials. It needs to know kind of it's not username and password, but it needs to know the username and password for accessing that bucket and storing the user images on S3. And the same goes for DynamoDB or any other Amazon service. The web server needs to have those credentials. And there are different ways of providing credentials to your instances in the Amazon cloud. One of those ways is to simply hard code those credentials. You can hard code them in your application. You could, in the source code, say access key equals something, access key secret equals something else, and there you go. That's not a good practice. So Amazon provides you with something called instance profiles. Instance profiles are a way in which an EC2 instance can, in a kind of automated way, get credentials from the metadata server, and using those credentials, access the different services. Okay? So all of this you need to configure. It's not kind of magic. You need to do it. You need to configure it. But once you have instance profiles applied to an EC2 instance, and from that EC2 instance you want to access S3, for example, the code running in that instance, for example, the code in Ruby, if you use Ruby, you're going to be using something called a library called fog. If you use Python, you're going to use boto. So those libraries running in that EC2 instance will know how to retrieve the credentials from the instance profile credentials from the instance metadata. They're going to simply know how to do it. So if you want to access S3, the code is going to go to the metadata server, retrieve the credentials, and then go to S3 and do whatever you need to do. The good thing for us was that the instance profile credentials are stored in the metadata server. And we had read access to the metadata server. So we could read those credentials from any location, and because of the initial vulnerability, we read credentials for that EC2 instance, and we can impersonate that instance with any other service from the Amazon cloud. Okay, are you following me? Yeah? All right. I know there are kind of many names and different things that you're not aware of, but I try to be kind of gentle with my introductions. Okay, so we have access to those credentials. So I wrote a simple tool called dump credentials that you can use to get those credentials from the remote server. You get the access key, secret key, and a token. If you configure those in your local workstation and you access Amazon services, you're going to be impersonating and you are going to have the same permissions than the EC2 instance that you're attacking and from where you retrieve those credentials. But the first thing is that you only have 3 strings that don't tell you anything. They don't tell you where or which service you can access. So I wrote a different tool called dump permissions, which is going to perform different steps in order to access the different endpoints of the Amazon cloud and test, using those credentials, test if you have access, if you have permission to run those API functions. After running this, I found that the permissions that this tool was able to enumerate is not kind of the whole permission set, but only the ones that we were able to enumerate. Excuse me. The permissions were those where it says statement, action, list queues, effect, allow, resource, star. At that point, I said, what is list queues? I don't know what it is. After a small Google search, I found out that list queues was a function in the SQS API from Amazon. SQS is basically a queue. When you're developing a web application and you want to run tasks that are going to consume some time, like processing video or something like that, from the front-end web application, you put a task in the queue, and then you have different workers which are going to be consuming those tasks and storing the result somewhere. So SQS. I have credentials to access SQS. Perfect. So I started Python, opened a shell, a Python shell, and connected to SQS using the credentials, just like you can see there. And I said, for that connection, get me all the queues that are present for that Amazon user, and for those credentials, give me all the queues. So I found a queue there that's called Nimbostratus Celery. And then what I did was, all right, give me one of the messages that someone stored in that queue. I get one of the messages, I inspect the body, and I find 2 different interesting things. First, content type, application X Python serialize. And the second interesting thing was routing key Celery. Perfect. Who knows what Celery is? All right, we don't have many developers here. Okay. I had SQS access, and I wanted to also check if I could write a message to the SQS queue. I tried that, and it worked. I was able to write and to read from that SQS queue. Perfect. But what is Celery? I don't know. I Googled Celery, and this is what I found. This is basically a way of abstracting the task of sending a message to the queue, serializing it in some way, sending it to the queue, and deserializing that message and processing it on a different server, right? Celery is just an abstraction for doing that. It does much more, but it's a good explanation. And it's usually used for Python web applications. It's really, really popular. So now, from an attacker standpoint, this is how it looked, all right? I had one front end or potentially more front end servers sending tasks to SQS, and because how Celery works and how SQS works, I assumed, and actually it was correct, that there were n workers consuming those tasks, right? Something interesting to note here is that if you take a look at this diagram, you will see that it seems that the SQS queue is outside of the reach of any attacker. But actually, sending a message to the SQS queue is not controlled by any firewall or anything like that. You just initiate a new SQS connection, and in this SQS connection object, you are going to have an API endpoint for SQS, which is going to be something like sqs.amazon.com, all right? So it might seem here that it's protected, but it's actually not. You can access it, if you have the right credentials, you can access it from anywhere. Okay, so it looked like this. I'm a graphical guy, so I always draw while I'm doing a pen test. So, Celery. I wanted to keep gaining access into this system, into this application. So I wanted to know more about Celery. When I went to the Celery documentation, I found this very interesting comment. The default Pickle serializer is convenient because it supports arbitrary Python objects, whereas other serializers only work with a restricted set of types. If I'm a developer, I stopped reading there. It's the default, and it's more convenient. So that's it. But if you're a security guy, you read the next line. But for the same reasons, the Pickle serializer is inherently insecure, and it had some link there, and should be avoided whenever clients are untrusted or unauthenticated. Okay, that was interesting. So, in the initial architecture that the developers defined for this service that I was pen testing, in the initial architecture, the clients for the SQS queue were authenticated and were trusted. But now, we stole those credentials for accessing the SQS queue. So that's not true anymore, right? And let's also investigate a little bit more about what Pickle Serializer actually is. This is how Pickle works in Python. Pickle is a way of serializing objects. You take an arbitrary Python object, you go through Pickle, and you get a string. And then you can take that string, go through Pickle again, and you get the same object, or almost the same object. But there is a vulnerability in the way that Pickle works, which if you control the string, that's going to be deserialized, you can execute arbitrary commands in that system where you are deserializing the string. And that's what you see there, right? Say pickle.load string, and you load an arbitrary string, and you execute commands. Cool. So going back to our target system, we know that we can write things to the SQS queue, and we know that the workers are going to deserialize whatever we send to the SQS queue, because that's how Celery works. And we know that it's using Pickle, because we saw it somewhere like there. XPython serialize, if you dive a little bit into the Celery source code, you're going to find that it's Pickle. So perfect. If I write something in a custom format to the SQS queue, which I can do, this guy is going to deserialize it, and if it's in the right format, I'm going to be executing arbitrary commands in the worker. Perfect. So I did it, and it wasn't hard. It was actually pretty easy. I wrote a way of automating this. Celery pickle exploit, you pass the credentials, and you say, I want a reverse shell to this IP address and this port, and I want you to write the very specific, arbitrary, kind of Celery-looking message to this queue, and this queue lives in this region, this Amazon region. So you run this, and on a different console in the correct server, you listen for connections, and voila, you're executing arbitrary commands in one of the workers. That's really good. And it's interesting to notice that we gain access to the first server that we gained real access is one server that's kind of 2 or 3 kind of architecture steps behind the front end, all right? So we gain access through a really strange access point. All right, are you guys following me? Cool. So we now have access to this server, to this worker. And we know for a fact that it will be running Celery. It will be running, it will be kind of retrieving tasks from the queue. And for retrieving tasks from the queue, it will need credentials, right? Because that's the way it works. So I started to look and to kind of browse the source code and to try to identify if that worker had an instance profile and different things. But actually what I found is that the credentials were hard-coded. In this case, the credentials were hard-coded. So I got the credentials for the worker, and I did the same trick as before. I dumped the permissions for those credentials, because credentials are just strings, they don't tell you anything. If you dump the credentials, you see something like this. In the second section, you see SQS star allow on any resource, which makes kind of sense, because you need to access SQS, you're a worker, you need a way of accessing the queue in order to run those tasks. But there is a misconfiguration there. Someone at some point made a mistake in this permission setup and put something like IAM star allow on any resource. And that's actually not good. Let me explain why. I'm going to explain that actually in the next slide. Also, when I was telling you about this architecture, I said usually workers, what they do is they take a task, they process it, it takes some time to process that task, and they store information, they store the result of the task is stored somewhere. In this case, that somewhere was in a MySQL database, which was hosted also in the Amazon cloud for this Amazon user. And how did I know that? Because if you take a look there, for the configuration for this worker, it says that the host where this MySQL database is, it says something like yada 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 .rds.amazonawebservices.com. That means that MySQL database is part of something called RDS. RDS is a managed database that Amazon provides. I tested this. As you can see, the user here is no root, and the password is some random password. I tried to dump that database. I was unable to do it. I tried to connect to the database. I was able to do it, but the information that was there wasn't really interesting. It was logs about the tasks that were run by those workers. And it was no root access, was boring. So this is how it looks now. My worker has access to a MySQL database. That MySQL database is hosted in RDS, and my worker also has access to something called IAM. Let's understand what IAM actually means. IAM is access management in Amazon clouds. That means that if you want to define an instance profile, you want to define a user, you want to define permissions, groups, and all of that, you go to IAM in your Amazon dashboard, and you do it there. The information and the configuration that you set there is also accessible through an API. And you can grant users access to that API. Here, by mistake, and this is totally the fault of the guy configuring the permissions, we had access because of this here. Because of this IAM star allow on any resource, we have access to performing any action in the IAM API. And that's actually interesting, because if we have that access, we can actually create a different user and assign any permissions to that new user. So let's do it. Why not? So we wrote a small script that does that. Create IAM user. If you provide the right credentials, it will be able to do it. And it will create a random user with a random name with all the privileges. That means that that new user will be able to send any request to any of the Amazon APIs, and it will succeed. Okay? So that's kind of getting root on the Amazon cloud for one user. If you have this, if you have all the IAM permissions, you are root for that Amazon cloud. Okay? So this is important. Just to verify, I dumped the permissions for the new access keys and secret keys, and it says that, yes, you have everything. You can do whatever you want. So I got root at that Amazon cloud. That was great. And I thought, what else? I was able to get access to the source code of the front-end web application. I was able to get remote code execution on the scan workers. I was able to access the MySQL database, but with a restricted permission set. So I said, I want all. I want all the information that's stored in that database. Not only the one that I can access with a no root user. As we said before, that MySQL was running, was running on RDS. And now I can manage, because of this privilege escalation, I can manage that MySQL database through RDS. Not only connect to it using the MySQL protocol, but I can also, at a higher level, I can manage that database. One of the functions that Amazon provides you when you have your MySQL in RDS is for you to run backup of that database. So we could create a snapshot. We could restore that snapshot with a different name also in RDS. And then we can set, because RDS also provides you with that API, and then we could set the root password for that restored snapshot, which has all the information of the original one. We could set the password there and connect to it. And I'm just doing this kind of snapshot and restore because I didn't want to change the root password of the original MySQL database, because that could break things, right? If someone is actually using the root user for something, some application is using it, and I change it, the whole thing breaks down. So I created a snapshot, restored that snapshot in an RDS, in a new RDS database instance, and then I changed the password. And I automated that, really simple. You pass the credentials and the new password, the name of the instance that you want to clone, the region where it lives, it runs, and after some time, you're able to connect to it with the new password, but containing all the same information that we had in the original database. I did it, I connected to it, I found some important database which I was unable to access before, with some new information, and I was kind of rocking the cloud at that point. And I was really happy. I was happy that I was able to do all this. I was happy that the learning process behind it was so interesting. And my conclusions here are rather simple. When I ask you guys a couple of questions about the Amazon cloud, and I ask you to raise your hands, not many of you raise your hand. And I'm a little bit disappointed. A lot of developers are storing and are hosting their web applications on Amazon or on different clouds. If you're interested in security, if you're somehow in charge of the security of those applications, you need to know all this. The developers are leading the way, and we need to help them secure the Amazon architecture that they use. So you should learn about Amazon, or you should learn about any other cloud provider that your development teams are using. In this specific case, Amazon provides a free tier kind of licensing, which you could use for learning. It's for free. You should use it. Most vulnerabilities here are misconfigurations, are kind of small things where the developers working on this application made mistakes. It's my impression that this is not Amazon's fault, right? This is the way in which they build things in this specific case. All right, source code. I told you that we had two different repositories or applications. One is Nimbostratus. Nimbostratus is a tool that I showed you during this presentation. It's a kind of complex tool to use because you need to be in an environment where you already have some kind of access to that Amazon instance setup. It's a post-exploitation tool. You are not going to just use it like Nmap. You just run it against the server and get results. It's kind of manual labor. But it's really good. It's well coded. You should test it. The second tool that I wrote is kind of a hack me cloud. It's Nimbostratus target. So because I know that not many of you have the time to set up an environment to play with Nimbostratus, I wrote a script which, if you just provide your Amazon credentials for the free tier, you provide those credentials, you run that script, and it's going to create, in your Amazon cloud, it's going to create the same, exactly the same environment that we saw during the presentation. So you run that script, you wait for, let's say, 10 minutes until Amazon does all the magic, and you have all the same environment running there. And then you can use Nimbostratus to attack it, to learn, to modify it, and to do whatever you like. One small hint and warning, or mostly, is that if you run Nimbostratus target, it's going to start different instances in the Amazon cloud. And when you finish kind of playing with it, shut down all the instances, because if you just keep them running there, you're going to start seeing kind of charges in your Amazon bill. All right. Okay, so this is me. Follow me on Twitter, send me an email, and visit my site. I have been working on a new project called TagCube. TagCube is a software as a service for scanning web applications, which is easily integrated with the SDLC. I've been working on that. So subscribe, test it. Hopefully you will like it. Questions? We have like almost 10 minutes for questions. There's a microphone there. Don't run away. Yes? Microphone guy? The microphone?
Hello.
Okay. Yeah, thank you.
So the tool that you wrote that enumerates the privileges that a given access keys have, where it tries out like all the different.
Sorry, I'm not hearing you well. Could you?
Sorry. The tool that you wrote that enumerates the privileges based on just trying out the APIs and seeing what works. Mm-hmm. Do you know if that leaves traces in CloudTrails for the failures?
Yeah. The question was if I suppose the dump permission tool leaves traces. Yes. if the service is well configured, it will leave traces of all the failures in the accesses. By default, I believe no log is stored for failure to access an API resource.
Okay. Not even in CloudTrails?
Sorry?
Not even in CloudTrails?
I don't know.
Okay.
Besides the catastrophic flaw of putting the credentials into the init file, it seems that the second biggest problem that you encountered was that they had opened up all the security groups. Because for you to be able to run that shell, since Amazon starts all the security groups as not open, was that something also that you discovered through the metadata, or was it?
The question was about the security group and how I was able to connect to the worker. The answer there is that I use a reverse connect. So the worker actually started a connection back to my server. So usually, I'm generalizing, usually security groups only restrict inbound connections to the servers, to the EC2 instances. And in this case, I was using outgoing traffic. So it worked because it worked. And I believe that usually it will work. Does that answer your question?
Well, I was wondering if you'd actually gone into the admin console once you had the credentials and changed that, because by default they're actually not open outbound or inbound. You actually have to set that up as an admin.
You're asking if I enter the admin console? Sorry, come again?
No, so the security groups by default aren't open. So I was just wondering if you discovered that you could actually get out of the security group from the worker node that was monitoring the SQS to have your shell session started.
Why do you say that the security groups by default aren't open? What does that mean?
Because as an admin, you have to set those up in AWS to allow any protocol in or out. They're default denied by default.
Yeah, but by default, outgoing is denied?
Even the machine sits within the security group. Somebody has to give it the port and the
Are you sure that outgoing connections are denied by default? All right, that's new for me. That's good to know. In this case, in the case of the application that I was pen testing, and in the case of the Nimbostratus target, they both have outgoing connections enabled for the workers.
Okay.
I still believe that outgoing connections is kind of very common in security groups, but I will double check it. It's interesting information.
And were you able to pull the application code as well as the database, or did you try?
The what, sorry? I don't hear.
So the worker code itself, did you actually go into the worker application area and pull source code as well?
Well, I had access to the kind of remote command execution in the worker. So, for example, the credentials that I got to access the RDS database, the MySQL database that was on RDS, was hard-coded there in the source code. So I was reading through that source code, but only mostly doing greps on it.
Okay, thank you.
Hi. Hi, this one's mostly for clarification, so forgive me if I'm wasting anybody's time, but I'm just curious, you mentioned early on that the credentials were in the user data scripts to access the AWS cloud, but you had mentioned on another point there might be common practice to access the metadata server for those credentials. Am I just misunderstanding, or would you have been able to access those credentials directly through the metadata server by proxying that request?
All right. There are two different sets of credentials in that front-end EC2 instance. Maybe I didn't explain myself well, but the basic idea is that in the user data script, you have credentials for pulling the source code from some repository. And you have a different set of credentials that's stored in the instance profile And those credentials stored in the instance profile is in the metadata server also, just like the user data is in the metadata server. But those instance profile credentials are for accessing different services within that Amazon cloud. Right? So there are two different sets of credentials. They don't have anything to do.
Okay.
The only common thing is that they are stored in the metadata server, but in different paths in that metadata server.
Gotcha. So the execution path that you took was to get through to the, you just accessed the web application server's source code using that link, and that's where you got additional information. Or did I skip a step?
I read the AWS credentials from the instance profile for the front-end web application, and I used that to gain access to the SQS queue.
Gotcha.
Right.
Excellent. Perfect. Thank you.
Any other questions? No? All right. Thank you so much.